In this video, we will walk through an example lesson. First, it's important to note that your students should have already had many and varied experiences with tiling, especially with regular and semi-regular tessellations. For this activity, you will need 10 to 12 squares. These can be made from a 10-frame template or graph paper, or they can be cut from construction paper. In order to prepare for this lesson for the classroom, each student will need 10 to 12 squares, a ruler, scissors, and Scotch tape. Consider accommodations such as left-hand scissors, adaptive scissors, and maybe even larger graph paper, inch-size graph paper. Today's task is to determine if we can make non-regular shapes that tessellate. You'll need to begin with one square and your scissors. You're going to make one cut along one edge of the square so that you have two pieces. This cut can have curves, it can have straight edges. It's up to you. So I began with my square, I made a cut along one edge. The next thing I'm going to do is slide one of the pieces to the opposite edge. Now I've created a non-regular shape. In order to make more of these shapes, I'm going to trace my cut it out, slide, and use Scotch tape to tape my pieces together. So I should have 10 to 12 non-regular shapes that all are exactly the same. Here are a couple other examples. This was my first attempt, and that's my cut. I can slide it over to the other edge, opposite edge, to create my non-regular shape. And this is my final non-regular shape. Another example is here. This was my cut. I slid this piece over to the opposite edge and created a new non-regular shape, and that is how it ended up. Now, if you want to try something a little more advanced, once you've done this and created a non-regular shape, you can then take one of the other edges, say the bottom edge, cut across, take that piece and slide it up to the opposite edge. Here's an example of one that I attempted. This was my second cut, which I can then slide across and tape to have another kind of non-regular shape, one created with two cuts. So take a few minutes right now and create for yourself a non-regular shape. Now that you're ready with your non-regular shapes, various copies of your non-regular shape, you are ready to begin exploring. This is the question we are going to ask ourselves. Does our non-regular shape tessellate? So we're going to take a few minutes now to determine whether we can tile with our shapes in a way that edges line up to edges, there's no overlapping, and there's no extra spaces in between. So take a few minutes and play with your non-regular shapes. Do they tessellate? So while you were tiling, what did you notice? What did you try? What else do you think you could have tried if you had more time? How did your shapes fit together? Did they repeat like mine do? Did they rotate? Did they flip or reflect? These are some of the questions you can ask your students as they are exploring, as you walk around the room monitoring. Once you bring the class back together, have your students share some thoughts. If we were working right now synchronously, we would take some time to share our thoughts, share our noticings, share some of the things that we found out while we were exploring with our non-regular shapes. So once you bring the whole class back together, you might want to ask, do all non-regular shapes tessellate? When might a non-regular shape not tessellate? You might go back to the question about what kind of transformations do you notice in the designs that you created with your tessellations. Depending on your objectives and on the noticings of your students, the whole group discussion could lead in a variety of directions. For example, you might try designing a non-regular shape where the cut piece is rotated to an adjoining edge, like this. Instead of sliding, what would happen if you rotated in this direction or rotated in this direction? Would this non-regular shape tessellate? You might explore how perimeter and area change or stay the same when a square is cut and reconfigured. For this example, you want to make sure that the measurement of the edges of the square are appropriate for the students that you're working with. For example, these squares are 1.5 inches per side or per edge, making a perimeter of 6 inches. And these squares on the graph paper I have created are 10 centimeters per side, making 40 centimeters as the perimeter to be 40 centimeters. The graph paper, though, is a good choice for students who are just beginning to have a good understanding of area. The design tessellations that you've created can also be displayed as artwork. So there are so many different directions you can go into, and definitely continue discussing those transformations. The sliding, the rotating, the reflecting. Depending on your age level, you might decide which terms you use for those transformations.